Hi, I'm Emily Baldwin reporting for ESA Web TV from the 49th Rosetta Science Workshop in Rhodes. And I'm with Matt Taylor, ESA's Rosetta project scientist. Matt, why is this meeting so special?
Well, it's so special because this year is the last time the US teams get funded to come to this meeting. So it's the last time we can come together as a full Rosetta team to discuss the science of the mission and also the operations and the archiving.
And the mission has been finished for nearly 2 years from an operational perspective. And what does that mean now for the focus of the mission?
Well, the focus has purely been on the science, and we're really hearing this week that the devil is in the detail, that the first results we had from Rosetta gave us an insight into the comet and comets in general, but now we're digging in with multi-instrument approach. It's really showed us that Rosetta has said comets are much different than we expected, and so we really have decades of work to do.
So if you could pick just one or two key science highlights that we're discussing this week at the meeting, what would they be?
I think it has to be the shape of the comet and what the implications are. Now everyone, not just the scientists, the public, were in awe of the fact that we were flying around this duck. That is really making it difficult to understand how activity works on the comet, how the coma grows, and how the comet changes its physical characteristics as it goes around the sun. That for me is a big one, and we're still trying to understand how outgassing works, what the mixture of dust and gases that comes off of the comet, because that tells us about the age of the comet and where it was formed, and piecing that all together, given the complicated shape of the comet, as well as the way that we found out it has seasons like we have on Earth, the fact that it has different behaviour depending on what part of its orbit it's on. That has to then be all backtracked to then go back to the question of how do comets work, how does this activity work, and the place of this particular comet in the overall evolution of the solar system. It's all still being discussed.
So how are the results from Rosetta helping to guide discussions when we're thinking about future missions to comets?
Well, once we finish the science discussions this week, we're going to move into what is the future for the community. There are potential missions to do sample return at comets. One of those could be going to 67P itself, utilising what we've learnt with Rosetta and going and getting a sample from it, which is actually what Rosetta was originally designed to do. There are other discussions about having multiple orbiters around bodies like comets and also asteroids to give you a perspective of the three-dimensional nature of the outgassing, the activity that's coming off, which is something we miss a little bit with Rosetta, so we have to model all of that. But the next step would be having different spacecraft around the comet to get an idea of that 3D nature.
Well, it certainly sounds like there's an intensive week ahead, and I'm looking forward to find out more about these exciting discoveries. I'm Emily Baldwin reporting for ESA Web TV.